All right. Hey, lovies. It's Dr. Chelle. Welcome to Dr. Test Prep. We are doing geometry and trig. And just because now I know how valuable Unit 8 is, if it's a couple days before your test, you haven't watched the Unit 8 playlist, please go do that. It will cover more questions than what I'm covering in Unit 9. Okay. If you have my book, which is underneath my cell phone, we're on page 176. You don't need my book. It's literally just the questions on the screen. It'll just keep you more organized. Please make sure that you have the Desmos calculator open and it's set to Choose Assessment College Board. Now, this is super important. Remember that now that it's a digital SAT, the questions will get progressively harder, which means you might get some questions relating to the unit circle, which is later on in this unit. Right now, your calculator defaults to be in radians. For any time we do trigonometry, we need you to go back to degrees. So you have to remember to flip back to degrees whenever you have trig questions, or else it will not work. Uber important. Next, trigonometry is sine, cosine, and tangent. You have to memorize the trig identities. If you stink at memorizing the trig identities, go into YouTube and there's a couple of very annoying videos, but the most annoying video is black and white. It flashes. If you have it's like strobe light, but it is the most annoying catching tune. You will be guaranteed to remember it. And it goes something like this. You know what it is. Sokotoa, Sokotoa. And then he keeps singing on and on. Sokotoa, Sokotoa, like a gazillion times. So I guarantee you're going to see a couple trig questions. You have to know the trig identities. They do not give it to you on the formula sheet. All right, let's go ahead and get started on Unit 9, Lesson 3 from Khan Academy, Right Triangle Trig. Here's question 1. A ladder is leaning against a wall. So here's my ladder. Boom. The angle of elevation is 40. The ladder is 15. How far up is the ladder on the wall, rounded to the nearest? So again, we've got so that would be opposite hypotenuse, ka, adjacent hypotenuse, and toa, opposite adjacent. If this is my angle, this is my opposite, and this is my hypotenuse, so I'm going to use sine. So I've got the sine of 40 equals x over 15. So all we do is we go over here. The sine of 40 equals x divided by 15. And it solves it for you. Rounded to the nearest foot, 9.6 rounds to 10 feet. Done. You don't have to remember to cross multiply, divide. You just have to type it into the calculator. Mind blown. And there's a lot of mind-blowing things in this YouTube series. You got to learn how to use a Desmos calculator. Your score will go crazy up. And if you practice in Khan, crazy up. All right, next one. An airplane is flying from New York to Miami at an altitude of 12,000 feet. The angle of depression is 18 degrees. So this is 18, and it's flying at an altitude of 12,000. What is the horizontal distance between the plane's current location and the airport? We just need that, okay, because it says horizontal distance. Based on this angle, there's a lot of ways you could draw the picture. This way works. It's accurate. We have opposite and adjacent, so we're doing tan. So we've got the tan of 18 equals my opposite, 12,000, over my adjacent, which is x. Guess what we're going to do? You can click here and do functions and then hit tan this way. I'm just so used to typing tangent, I just type the word tan. Equals 12,000 divided by x. Now you're like, Doc, I don't see it. Yeah, we're talking about like 12,000. So we're going to go up to the little wrench and we're going to make our x-axis like 20,000. Like we're making it huge. That doesn't work. Let's make it 50,000. And there you go. Here's our line right here. To make it easier, just type y equals 0 and it'll give us the intersection a lot more easily. So what is the distance? It is 37,050 feet. The other thing you could have done is, if you remembered, you could have just done 12,000 divided by tan 18 and you would have gotten like the same amount. Okay. Give or take. And actually I probably should have scrolled in more so we could see that that is actually the correct thing right there. Zooming in, round it to the nearest foot. Moving, 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 moving. So that's the better thing. Just keep zooming in. I got lazy. So zooming in, we can see our answer is 3, 6, 3, 2. And I missed the 9 in the middle. Don't be lazy like me. All right, next one. An isosceles right triangle has a side length of 9. What is the measure of the acute angle? This one, you don't even have to think. Isosceles means these two are the same and it's a right angle. Because these are the same, these are the same. The side length is just like, okay? You could figure it out by doing like an inverse or something, but don't bother. It's a right triangle and isosceles. If this is 90 degrees, that means there's 90 degrees left for these two angles. They're the same. 9 divided by 2 is 45 degrees. Okay. I'm going to keep the calculator in Desmos. Actually watch what, let's see what happens. When we hit the gear and delete all to recenter, it does put us back at radians. So if you use the gear tool, make sure you go back to degrees anytime you have trig. When you come back, we're going to do page 177, which is looking at some harder questions. Goodbye. I'll see you soon.